While a lot of different rovers and robots move around the world using wheels or mecanum wheels,
this is a ballbot drivetrain.
This robot rolls around on 4 different spheres.
Yeah, each of these have a single bearing in each side.
In this FTC Robots Revealed, we're getting up and close behind team 11308 YISE. Now, the interesting thing about this ball drive is it actually controls the exact same way as a mecanum drive does. Now, we're visiting this team here at the World Championships for the FTC Decode season.
Let's talk about your drivetrain first, because that's quite a unique thing about your robot.
All right, so this is by far the most unique thing about a robot and one of the most unique things at this event. So this is a ballbot drivetrain. So to go into the history of this, there was a research paper in 2008 by a Japanese university that outlined a ballbot-like system. The concept was later picked up by a couple smaller Tech 2 YouTubers who did a few videos on it on RC cars. And then finally, a FRC mentor who mentors a couple teams in New Jersey actually took this design and decided that it would be a good platform to make on FRC robots on. He posted a quick blog post about, hey, we would like some FRC teams to come and try this out. And when nobody was interested, we saw the post and we figured we could adapt this down to an FTC scale. So this was designed as an alternative to swerve, which means each of these modules has a lot of traction and a very large contact grip with the floor, which still works appropriately when scaled down. You can see on some of our earlier prototypes, they have a...
show it on here? Oh, just put it on the table?
Yeah, on some of the earlier prototypes, we have a lot of grip and we actually have studs. This is because FRC is played on carpet and they can have a lot more traction with their heavier bots. With our drivetrain, we had to adapt to smoother and smoother skins, whether from fuzzy skin TPU or this all smooth TPU that you see here on the tires we have currently. So this is an X-Drive system, which means it's like a traditional X-Drive OmniWheel system, except each OmniWheel is replaced by one of these modules, these units here. So each of these is 90% 3D printed, and the only non-printed parts are the hardware and the bearings on the inside here.
And you had one that was on the inside. Can we split one apart to take a look on the inside?
Yeah, can we put the other halves on? So each of these units are comprised of 3 main pieces. Each of these outer cells, which are a removable tire and an inside, and then these inside cores. And these cores contain a small wheel on the end, similar to an OmniWheel drive. You can think of these like Omni wheels, except instead of a series of smaller wheels around the outside, each entire hemisphere rotates freely around a center roller, because you only need one point in contact with the floor and the rest can rotate freely.
And can you have a really large internal ball bearing on the inside of that as well? That's how one half of it rotates, yes?
Yeah, each of these have a single bearing in each side. So you can see some of our earlier prototypes had roller bearings, and our current prototype uses these large ring bearings here.
This is not for model. This model was completely fine. As you can see, that's very puffy skin. That's because we wanted to go for as much grip as possible. However, the problem was this clogged the maps. So, and that was bad. So we eventually moved to a smooth on skin, smooth on tile and same with it. Yet that's still got a yellow form. That's why we landed on old point.
Super cool. Yeah. And then this controls the same programmatically like a mecanum drive does.
So that is one of the cool things, is exactly drag and drop as the mecanum. Same exact math and formula, allowing you to even more rookier teams who don't have their same like full-on custom like PID auto programs like us. We actually use Roadrunner and Pedro pathing. And this was just a direct drag and drop when it comes to the drive code.
So why might a team want to use this? Why did you choose to do something like this?
So one of the advantages of this design is that since it was originally designed for FRC, you have swerve-like performance. And swerve is a very difficult thing to pull off an FTC. With your motor limit of only 8, it is difficult to use both motors per wheel. And so a lot of teams are trying to use like Axon servos, which are expensive and hard to find and difficult to program. There is also a lack of software libraries for swerve and FTC. So the advantage of this is that you only need these 4 drive motors. You don't need any extra servos or any extra control, and that it can use any off-the-shelf pathing solution. So you don't have to worry about making your own code and your own hardware on the same year.
Super cool. All right. And then let's take a look at your intake. How does that function?
So this is a 3.5-inch diameter rubber band intake. It is powered by a single Gobilda yellow jacket motor, and it also has these bevel gears inside of the channels that attach to these boot wheels. And these actually allow us to pick artifacts out of like corners and other hard to reach spaces without having to move the entire robot. So an artifact can come in and it can just sweep straight into the center.
Mm-hmm. And then how do you get it up and over that little shelf to get it up inside of your...
So we have a ramp, and on this ramp there is a magnetic limit switch, physical limit switch, sorry, that actually presses each time an artifact enters.
Yep.
There is then these two smaller boot wheels that sweep it the rest of the way into the actual indexer.
Okay. And then you've got a spindexer as well. Is that the idea?
This is a front-loading spindexer.
Mm-hmm.
So contrary to popular spindexer designs that have 3 or more walls, this does not require any rotation to intake artifacts. All artifacts can be swept in at once, and they can be automatically sorted as they outtake with this little flipper right here.
Okay, sorry, I got to take a look at that flipper.
Okay, yeah, here's the flipper again.
Okay. And that little flipper just pops out on a little servo.
Yep, just pops out and can...
And as it rotates, it drives up that little ramp. Is that the idea?
Yes, so as they go up the ramp and then round and then up into the axle seat.
Cool. And then how does your turreted flywheel end up working?
Yeah, so this is a turret-mounted underhand flywheel system that has these dual Andy Mark Stealth wheels and a rack and pinion controlled dynamically adjustable hood. This is because since our loaner allowance only allowed for a single motor on our archetype for this suitor, we needed a way to be able to control slots without controlling the speed. And this is where the hood comes in.
Mm-hmm. And it looks like you're driving this with a belt around the whole system, is how you're moving the turret itself?
Yes, the turret is belted from a single Rev Hex motor down at the bottom.
Mm-hmm. Then I noticed on a lot of your Rev Hex motors that you have like a little daughter 3D printed part inside. What's the 3D print between the cartridges?
So there's some issues with these Rev motors, namely that if you try to torque them down all the way, the internal gears in these external gearboxes will compress and they will bind up. And so in order to be able to actually Loctite these motors and make them useful for active use, we will put these little 3D printed spacers that we designed in there. And that allows us to clamp the motor down all the way and Loctite it without having to worry about the gears ever binding up or seizing.
Mm-hmm. That's really nice. Really nice. Yeah. Super slick. And what kind of automations do you use for your drivers to make your life a little simpler?
So we have 3 Gobilda RGB indicators that work as an LED strip. So we have 6 Rev V-free color sensors inside to detect the color of the balls that we have, as well as this analog limit switch on our ramp. So these 3 indicate states. So one of our states is driver is lined up, ready to shoot. One of them is we detect an April tag, but not quite ready. One of them is we don't have anything, or we're intaking. So these just tell the drivers things that they couldn't necessarily see. And that's also why we chose this clear plexiglass as our shielding. It allows us to actually see what's fully going on when it comes to debugging without having to take many things off and apart.
And it's acrylic or is it polycarbonate?
These are polycarbonate, a specific brand of polycarbonate called Lexan.
Okay.
So these are our machines.
Mm-hmm. Okay, cool. And then if I were to ask you what you're most proud of, you'd probably say your ball drive, I would imagine.
We would say our ball drive. It started as an off-season project and we've spent more than a season working on it.
That is super cool. And then if I'm correct as well, you guys also have the CAD model up online for other teams to take a look at.
We use OnSafe for all of our CAD. So you can go to this QR code right here and you can see and download all of the CAD.
Yeah, I'll put a link in the description down below.
Oh, that's even better. Yeah, that works.
Awesome. Well, thanks so much for sharing your robot, guys. This is really, really cool.
Of course. Thank you for coming by.